Okay, here are solutions for quiz 3 for Math 251. First question has to deal with continuity, specifically whether or not this piecewise function is continuous or discontinuous at x equals 2. So what you need to know is to be continuous at x equals 2, maybe I'll write this, to be continuous, we need the limit as x approaches 2 from the negative side of f of x to be the exact same as the limit as x approaches 2 from the positive side of f of x, and those two things have to be the exact same as f of 2. So really we got three different problems to work out. First, the limit as x approaches 2 from the negative side of f of x. Well, if x is a little bit less than 2, I'd be using this top rule right here. So I would try to figure out what is the limit as x approaches 2 from the negative side of the absolute value of x minus 2 divided by 2 minus x. Well, if x is a little bit less than 2, a little bit less than 2 minus 2 is a negative number. So what the absolute value symbols do is change the sign of the thing inside the absolute value symbols. What I'm saying is you can drop those absolute value symbols if you take account into the fact that they change the sign of this x minus 2 right here. So I got to evaluate this limit here. Well, I can do that in one more step. The limit as x approaches 2 from the negative side of this. Well, the negative of x minus 2 is just 2 minus x, and 2 minus x over 2 minus x is just 1. So this limit right here is just equal to 1. That's this guy. So now I guess I should figure out the limit as x approaches 2 from the positive side. The limit as x approaches 2 from the positive side of f of x. Well, now x is a little bit larger than 2. So I'm using this rule here. And so let's see, to evaluate this limit, I want to figure out what's the limit as x approaches 2 from the positive side of x squared minus 3x plus 2 over x minus 2. Can't just change all the x's into 2's because this thing's not continuous, but hopefully I can cancel out an x minus 2 here with an x minus 2 up in the top. Let's see, the limit as x approaches 2 from the positive side of, if I factor out the top, I need two numbers that multiply to positive 2 and add to negative 3. That's x minus 2 and x minus 1. And so I can now, maybe up here, cancel out those x minus 2's and get that this is the limit as x approaches 2 from the positive side of x minus 1, which is just 2 minus 1, which is just 1. So this right here is just 1. However, that still doesn't mean that we're continuous at 2, because those two numbers also have to be the same as f of 2. And to figure out f of 2, what I do is I say when x equals 2, I use this rule right here. F of 2 is 2 divided by 2, which is also 1. So because these are all equal, my function is continuous at x equals 2. All right, moving on. Find the slope of the tangent line to this function at x equals 4 using both the definition of the derivative, and the difference quotient. Okay, so I guess if I'm going to ask you to use the definition of the derivative and the difference quotient, I should make note of what those things are. Those are listed over here. So if I want to use the definition of the derivative, I'll kind of take this formula here, although I don't want to know what f prime of 4 is. I want to know what, I guess, g prime. I don't want to know what f prime of a is. I want to know what g prime of 4 is. Well, using that formula, I could say that g prime of 4 is the limit as x approaches 4 of g of x minus g of 4 divided by x minus 4. And g of x is the square root of 2x plus 1, and g of 4 would be the square root of 2 times 4 plus 1, which is the square root of 9, which is just 3. So what I have is the limit as x approaches 4 of the square root of 2x plus 1 minus 3 divided by x minus 4. And we have a trick for evaluating limits like this. We multiply the numerator and the denominator by the conjugate of the numerator to get rid of that square root. So I'm going to multiply by the square root of 2x plus 1 plus 3. I'm going to do that on both the top and the bottom. And maybe up here, I could say that that is equal to the limit as x approaches 4 of, if you FOIL out the numerator, you'll get 2x plus 1 minus 9. And in the denominator, you'll have x minus 4 times the square root of 2x plus 1 plus 3. Okay, so I got the limit as x approaches 4 of 2x plus 1 minus 9 is 2x minus 8, which is the same as 2 times x minus 4. And the reason I write it like that is now I can cancel that x minus 4 with this x minus 4, which has been causing all this trouble all along. Make it a lot easier to evaluate the limit. So I just got the limit as x approaches 4 of 2 divided by the square root of 2x plus 1 plus 3. And I can evaluate this limit by changing all the x's into 4's and getting 2 divided by the square root of 9 plus 3. In other words, 2 over 3 plus 3, or 2 over 6, or 1 over 3. So that right there would be the answer. And now do it all over again, except instead of using the definition of the derivative, use the difference quotient. Okay, well here's the difference quotient here. The difference quotient tells me that g prime of 4 I can find by evaluating the limit as h approaches 0 of g of 4 plus h minus g of 4 divided by h. So that's the limit as h approaches 0 of, if I take my function g of x and put in a 4 plus h everywhere I see an x, I got the square root of 2 times 4 plus h plus 1 minus the square root of, let's see, g of 4, we already saw that that's the square root of 9, which is just 3, and divide that by h. And my trick is going to, again, be multiplied by the conjugate. So I got the limit as h approaches 0 of, you can clean that up if you want to. Yeah, I'll do it. Why not? The square root of 2 times 4 is 8, plus 1 more is 9. And then 2 times 8 times h is 2h. And so I'll multiply the numerator and the denominator by the conjugate of the numerator. So I get the square root of 9 plus 2h plus 3 on the top and the bottom here. And it looks like I got a little bit more room here. Say that this is the limit as h approaches 0 of, if you multiply out the top, you'll get 9 plus 2h minus 9. 9 plus 2h from multiplying these two guys, minus 9 from these guys. The outside and the inner terms will cancel. And then the denominator, you got h times the square root of 9 plus 2h plus 3. Jump up here. 9 minus 9 is 0, so really all I have is the limit as h approaches 0 of 2h divided by h times the square root of 9 plus 2h plus 3. Hey, look at that. Those h's cancel. And I get that this is just the limit as h approaches 0 of 2 divided by the square root of 9 plus 2h plus 3. To evaluate this limit, change all the h's into zeros, and you get 9 divided by this, 2 divided by the square root of 9 plus 0, so just 9, and then plus 3. So once again, you get 2/6, aka 1/3. Oh man, I got another one to do. Hope I give you a lot of time for this quiz. Determine the slope of the tangent line to this function at x equals 4. I want to change this. I don't want you to do that. I'm going to change this problem. I'm going to make this 1 over x squared. I think that'll be a little bit easier. H of x equals 1 over x squared. Yeah, okay, so I just made the change. This is the new problem you're going to be asked, and you can do whatever the hell you want, the difference quotient or the definition of the derivative. Which do I prefer? I don't care. I'm guessing most of you will use the difference quotient, so I will use the difference quotient. I guess if I was especially ambitious, I could do it both ways, but it turns out I'm not especially ambitious. Sorry. So h prime of a is the limit as h approaches 0 of h of, this kind of looks weird with the two different h's, but that's fine, h of a plus h minus h of a divided by h. So I get it's the limit as h approaches 0. These are two different h's. This h represents the function, and this h is the thing that I'm taking the limit approaching 0. Anyways, it'll go away now because h of a plus h, I can get that that's just 1 over a plus h squared. And h of a is 1 over a squared, and that's all divided by h. And so when you see these fractions inside fractions, the trick that you immediately think, maybe, is to get a common denominator. So I will say that this is a squared over a squared times a plus h squared minus a plus h squared over a squared times a plus h squared. And that whole thing gets divided by h. Might look impossible, but it's actually not that bad because now I have this common denominator, so the whole thing is divided by h. And I have this common denominator of a squared times a plus h squared. And above that I have this a squared, and then from that I want to subtract a squared plus 2ah plus h squared, which is the same as a plus h squared. And a nice thing happens when you do that. A squared minus a squared just cancels out, so I'm left with negative 2ah minus, I bet a lot of people forget that minus, h squared, divided by a squared times a plus h squared times, instead of divided by h over 1, I'll multiply by 1 over h. If you factor out an h from each of these two terms, you can cancel it out with this h down here and call this negative 2a minus h over a squared, a plus h squared. And because I've canceled out this h, I can evaluate this limit. I can change all the h's into zeros. If I do that, this goes away, this goes away. I'm left with negative 2a divided by a squared times a squared. A squared times a squared, isn't that just a to the 4th power? Sure is. Wait, a divided by a to the 4th power, isn't that just the same as dividing by a to the 3rd power? Yup. Really, I'm fine with any of these as your answer. So I guess I answered it using the difference quotient, and sorry if you use the definition of the derivative. It's been a long day. I think I'm done making math videos.